Many will undoubtedly remember this past winter in Pennsylvania as the winter that never was, while others may recall it as the winter bookended by big snows. First, we had that historic early season storm just before Halloween that dumped as much as 10 inches of snow, even in Lancaster and York counties, with the highest amounts generally on ridgetops and in the Laurels. Then this past Sunday and Monday, we had its late season counterpart that brought nearly 2 feet of snow to the highest elevations of the Alleghenies. Such a heavy, wet snow in mid to late April is sometimes called a sapling bender snow for obvious reasons. To get a late season snowstorm, the mid-levels of the atmosphere have to be really cold, in part to compensate for the low levels, which tend to be warming up. If we go back to late Sunday, you can watch the core of coldest mid-level air associated with this storm, indicated here by the bluish colors, pass right over Pennsylvania on Monday. In late season snows, the heaviest accumulations tend to occur just to the west of that mid-level cold pool, and that's what happened here. This week's snow conjured up memories of the storm against which all late season snows in Pennsylvania are measured from late April in 1928. Here's a sequence of mid-level temperature maps from that storm. The core of mid-level chill passed south of the state and then slid through eastern Pennsylvania, so heavy snow also fell in the northeastern and central parts of the state from this storm. Now here's some totals from that storm. More than a foot fell in Montrose, Freeland, and Dushore. Early and late season snows tend to be very elevation dependent. Those places are all above 1,500 feet, while Scranton and Towanda are at 800 feet or below. Wellsboro and State College both had a foot or more from that storm, while Williamsport, at only about 500 feet, only had an inch. The highest totals in the state were in the Laurels, where Horseshoe Curve near Altoona got 23 inches, Ebensburg 20, and Somerset 31. That's the most snow measured at an official observing site in Pennsylvania for any April storm in the last 100 years. Now, to get a sense for how elevation makes a difference in a late season storm, here I've plotted snowfall in inches versus elevation in feet for about 30 places for which I have data from that 1928 storm. Notice that in general, the higher the elevation, the greater the snowfall. A statistical procedure called linear regression can plot the line that best fits the data. Here it is. Turns out that about 75% of the variation in snowfall can be explained by its linear relationship with elevation. Now here's that same chart for this week's storm. I started the elevations at 1,000 feet because snow didn't really accumulate below that. Now there is one outlier here. This is legitimate. This represents Laurel Summit in Somerset County, 23 inches up at 2,730 feet. And now here's the line of best fit. This simple linear relationship actually explains about 80% of the variation in snowfall, just by correlating it with elevation. Well, we'll see if any more snowflakes are in the cards when Fred returns with the extended forecast next.